Hi everyone, this is a really quick video about PC fans and PC fan control. For background, if you want to watch it first, it might make a little bit more sense. I just watched this video with Deb Bauer and Steve from Gamers Nexus talking about a motherboard support system that he's making, Deb Bauer's making. And what was interesting to me is he's chosen to give that to fan in ports, and then he can switch which of those connectors the fans are paying attention to. What he's doing makes sense for how he's trying to do things. He wants to test graphics cards in isolation and report what their performance is. He wants to be able to test CPUs in isolation and report what their performance is. And all he has to do is flick that switch to get it to work from based off one or the other. That's a pretty good system for what he's trying to do. And it lets him validate that when the CPU gets hot, the fan is being controlled appropriately, and when the GPU gets hot, that fan is being controlled appropriately, and it eliminates interference from the other part of the system. I have a problem that on the surface seems similar, but because my rationale and what I'm trying to achieve are completely different, what he's done would not help me out particularly. I have my workstation system, which has a GPU that has controllable fan output on it. I obviously has a CPU fan header. I have a system level thermal problem with the case that I've currently got. So like the actual thermal limit that I hit more often if I don't run the fans at a high enough speed is that the SSD will overheat and drop off being connectable, and so I'll lose my D drive, which is inconvenient. I also obviously, there's other thermally sensitive components in there, like the chipset is the fourth major one that I could have information about, and I currently am doing nothing with. I've got 4 measurable temperatures that I can only really measure either with software that's programming I2C or SM bus information, which I don't like because that relies on the operating system being up, competent, and giving slices to whatever's doing that monitoring. And it relies on having low-level drivers to access those pins on the CPU, frankly. Neither of those things I want. I don't want to rely on that software getting scheduled, because if I'm running something that's trying to use 100% CPU, I really want all of that CPU used for the task I'm asking it to run. And so if I've got aggressive with the priority of that, it would just mean that my fan control stuff doesn't get executed, which would be bad if I was relying on that to keep the system cool. And also I switch operating systems from time to time, like I switch from Linux to Windows. I would like to try SteamOS on this system at some point, maybe. And I just would like my thermal controls to not be affected by that change. I don't want to have to rebuild my control system because I just happen to switch OS. I run a full water loop. How good of an idea that is mixed. It means my CPU is super cold relatively, my GPU is super cold relatively, but there's not as much inherent airflow over the memory. I have gained thermally on the major ICs, but I have lost out thermally on these minor systems. And as I say, that has impacted my life in the last couple of days in that my SSD has overheated and turned itself off a couple of times. Now what I'm doing about it is I'm going to take a Raspberry Pi Pico with the number of pins I've got available on that and the software and hardware features that it's got. I can readily read 4 input PWM signals, which is what I'm going to use to get the information from the GPU, the CPU, the main board, and the chipset as to how hot they believe that they are. I need 4 pins to send back a fake fan tachometer reading for each of those fan connections so that the connected device doesn't start thinking that there's no fan connected. So that's 8 I/O pins just for reading what I'm being asked to set fan speed to and lying about how fast the fan is spinning. Then I need 8 pins to output PWM signals to control the fans in my case. And then I need another 8 pins in order to read the tachometer signal from those fans that I'm controlling, or the pump, and so that I can know that what I've asked to do is working. This is editing Phil interrupting previously recorded Phil. I don't know if you can hear it or if I'll be able to noise suppress it enough, but the fans in my PC are going nuts, and that's what I have to do at the moment to get good stability. The way it's going to work as a physical product, my prototype, is I have this 3D printed thing which is the size and shape and screw hole layout of a SATA drive 2.5 inch version, because I'm not using the 2.5 inch drive mounts on the backside of the motherboard in my case, so that's going to be convenient and secure way to mount this. This is the core of the electronics. So this is a Raspberry Pi Pico, this board here, that's the main chip. All of these pins on the side are either ground or I/O pins basically. All of the I/O pins and grounds are going to get connected to the inner rows of these boards here. Each of these boards contains 4 MOSFETs, N-type MOSFETs that are designed in a architecture that creates a level shifter. They're marketed as for 3.3 volts to 5 volts, which is some of what I need. But with the chips that they've used and the topology, it will safely do 3.3 to 12 volts, which is the other one I need. So what I've done is I've bought this Serial 88 extension cable, cut it, and I've got then a fly out of 12 volt ground, 5 volt ground. What I'm trying to do is get the decision, like the information of what we're being asked for from up to 4 fan control sources into the input side of some software box, and the control of up to 8 fan destinations as the output of this fan control box. And then I'm going to implement in that software bit in the middle whatever I feel like. I could probably connect a thermocouple up to this and just run it off the water temperature. And then the only reason it's connected to the host system or the system it's cooling at all is in order to lie to it so that it will boot without warning that there's no CPU fan plugged in. I'm satisfied in my own mind that I could fit all of this electronics and the 12 4-pin fan connectors that are required into this footprint. I think that makes it possible that there's a product here at the end of it that other people might want to buy. I personally have no great interest in becoming a manufacturer of these devices. If you all want it, then maybe Harris Thermal Grizzly to make it a product. I will, if Debao wants it, give him the schematics and the source code for the fan control logic. No strings attached. I will just say this before anyone who's a fan of level 1 techs pointed out. Yeah, if I bought a server grade motherboard with a proper system management engine in it, it could control the fans in this way for me. And yet, yes, exactly, I am building the fan control only part of a system management engine. But what I'm really trying to do with this setup is get back to how I had it in my previous total custom case, where I had a constant fan level, nothing ever got too hot, and that constant fan level was acoustically quiet enough to not interfere with anything else that I'm trying to do. So one of the constraints on when I can film now is the with the system set up as I have it now, I haven't found a way to get a constant fan noise configured in the BIOS that's at a level that I can live with and that I can film over. So I have to limit when I can film to periods of time where I can turn the machine off. Hope you've enjoyed this brief episode. Thank you, and goodbye.